All right, now we got to work on concentrations of solutions. All right, so that'll be our next step, and hopefully it'll help us get where we need to go, because we need to understand how these things work and how to go back and forth in those units. So, all right, so here we go. Concentration. Now, concentration of solutions is not super difficult, and so hopefully we can get through this one pretty quick and painless for y'all. And so concentration is just how much stuff is dissolved. So how much stuff is in the solution? That's all we're looking for when we talk about a concentration. The most common one that we're going to use is called molarity. And we use big M, and what molarity does is, okay, so molarity is the moles of solute divided by the total volume of solution. Now, this is expressed in liters, okay? So it is moles of stuff dissolved divided by the total volume of the solution in liters, okay? Not so difficult. Pretty sure we did this last year, but I'm just making sure we did it, okay? So if I have a 1.00 molar solution, and I have 1 liter of it, well, it doesn't matter right now. We'll just say it's 1.0. We would write that as 1.00 big M. And so that means that 1 liter, so that solution would contain 1.0 moles of whatever it was if 1.0 liters was poured out. Okay? And we can figure this out. We can put stuff in. We kind of work back and forth sometimes and work through a whole bunch of that stuff. And so I'll show you what I'm talking about. Now, if we were going to talk about what is the molarity, so let's do an example problem. So what's the molarity of a solution made by dissolving 17.5 grams of Na2SO4 into enough water to make a 1.5 liter solution, into enough H2O to make a 1.5 liter solution. Okay, and so this is a pretty easy problem. Pretty standard for molarity stuff. We're not going to stay on these very long. We're going to be out into more difficult problems fairly quickly. So, all right, here we go. So, first thing we want to do, grams has to get to moles. Okay, so 17.5 grams of Na2SO4, okay, over 1. We go to Your Friend and Mine, The Ultimate Party Planning Guide, the periodic table. We find out its molar mass. We find that 1 mole of Na2SO4 has a mass of 142.1 grams. Okay, so grams go away, and so that tells me that we have 0.1232 moles of Na2SO4. Okay, so now we've got one part of it done. The molarity of that solution is going to be that number of moles, 0.1232, divided by the total number of volume of solution, which is 1.5 liters. And so we do the math on it, we end up with 0.082 molar. And so that's how molarity is calculated. Okay. We can also do this for ions too. Okay, and so we can figure out what the molarity would be for an ion, and it's the same sort of situation, but remember we have some stoichiometry inside there as well. And so let's do that quick over here. So a molarity of an ion, or of ions, well, So let's say we have 0.073 molar CaNO3 what would the molarity of the nitrate ions be? Okay, and so, well, molarity is moles per liter. We don't even need to know the volume, it doesn't matter. We start with the molarity. Okay, so let's get this out of the way so we can differentiate here. So start with the molarity. So the moles of NO3 minus, or the molarity of NO3 minus, is going to equal 0.073, and this is my moles of CaNO3, 2 over 1 liter of solution. We're going to multiply this by the fact that we have, for every 1 mole of CaNO3, 2, we're going to make 2 moles of NO3 minus. Okay, and so 0.073 times 2 divided by 1, well, the molarity of that solution is going to be, of just the nitrate ion, is 0.146 molar, and that's my nitrate ion. Okay, so it's pretty easy to work with. It's not a super hard process, but just one thing I wanted to show you. Now, we got a little bit more to do with this one. Give me a second. I'm going to erase all this mess and we'll come right back. Alright, so now sometimes we might have to play around with the molarity and actually figure out how many moles are there, or calculate how many liters of a solution we need with something like that. And so the easiest way to do that is just remember some algebra. So molarity is going to equal your moles of solute divided by your liters of solution total. Okay, so now whenever we're doing this, all we're doing is algebra. We're going to solve, we're going to pick a variable, we're going to use the other two to find the third variable. And that's just, yeah, you guys can do this, all right? So, an example. So how many moles are present if I have a 0.75 molar HCl solution with a volume of 0.199 liters. Okay, and so solve for the variables. Put in what I have, find an x, put an x in, and then solve. All right, so I have molarity, so that's that number. So I have 0.75 big M. I have a volume, 0.199 liters, and I have X moles. Okay, so just like algebra in class, in your math class, multiply both sides by this number, 199 liters, and that'll clear that out. What I do to one side, I have to do to the other. 0.199 liters. Now, remember molarity, though, is moles over liters. And so I'm going to get rid of that. Liters cancels off. That leaves behind units of moles in the top, which equals moles over here, which is what I got. And so all I have to do is multiply that times that, and that tells me the number of moles of HCl that are present. Okay? So my X moles of HCl is going to equal 0.14925 moles of HCl. Okay? And they're no different. You can solve for anything using the same process. Okay? The only thing that would be different is if I had an X on the bottom. And if that was the case, then I would have to multiply through by an X before I started canceling everything out. Or I'd have to take the inverse of it when I finished the math. Not a big deal. You guys can do that. I know you can. So, all right. Now, what happens if I'm diluting this down and I need to do some calculations? Okay, this is the last thing we're going to talk about in this video. So, dilution. Well, a dilution means that we're adding water. And we are trying So we're adding water to make a less concentrated solution. Okay, so that's how we're going to do that. Okay, now the easiest way to do that is to use this formula. M1V1 equals M2V2. Okay, M1 is my original molarity, so that's initial molarity of my more dilute or my more concentrated material. V1 is the volume of initial needed. I'll show you that in just a second. M2 equals the molarity I want after I dilute it. And V2 equals the new volume that I want. So let me show you what that looks like in a problem, and then we can give this one a kiss and be done with it. So, hang on. All right, so let's suppose that I need for a lab I'm doing with somebody, let's say that I need a 0.75 molar copper sulfate solution, CuSO4, and to get everybody through the lab, I need 2.0 liters of it. Okay, so this is going to be my M2, this is going to be my V2. Now, if I go back into my chemical stock room and I start looking around for copper sulfate, I need a concentration bigger than this that I can dilute down and hopefully have enough. Okay, so let's say that I find I have a 2.0 molar 2.0 molar copper sulfate solution that we're going to start with. Okay, so this is my M1. All right, so what I'm trying to figure out, and maybe I could draw one of my amazing pictures because you guys know that I'm an amazing artist. No, I'm not going to bother. What I want to figure out is how much of this copper sulfate do I need to start with, this stuff. I'm going to pull a sample of it out. I'm going to dump it into a beaker, and then I'm going to top this off with enough water to make 2 liters. Okay, so what I'm trying to calculate is how much of this am I starting with. Okay, I'm going to use M1V1 equals M2V2. I'm just going to jump right in. V1 is my unknown in this case, so I'm going to put an X in that. So 2.0 moles, molarity, is going to be X V1, which is liters, is going to equal, I want a 0.75 molar solution when I'm done, and I need 2 liters of it in order to do our lab, whichever group is doing it. Okay, so I want this by itself. These two are being multiplied together. To get this alone, I have to do the opposite mathematical operator. So I'm going to divide that by 2.0m. What I do to one side, I do to the other side. That cancels off, leaves me in volume on this side. So now molarity is going to divide by molarity. It's going to leave liters in the numerator here. And so we did it right. It's the right setup. Okay, so how many liters of this do I need to dilute to 2 liters? Well, let's do the math and figure it out. 0.75 times 2 divided by 2 is going to be 0.75. It's like I picked a number that, wait a second, hang on, 0.75, 2 and 2. Yeah, okay. I changed my numbers for my sample, so it threw me off a little bit. Okay, so in this case, and that's probably going to throw you off too, so sorry about that. So my X volume in this case is going to be 0.75 liters. Okay, so in this case, I'm going to take 0.75 liters of 2.0 molar CuSO4, and then we're going to dilute it to 2.0 liters, and that will give us a 0.75 molar CuSO4 solution. So that's how dilutions work. Okay. Yeah. There we go. So cool.